Welcome to Renika Infotech. Today I have reviewed a laptop. It's a 10th generation i3. It's a HP laptop. Okay. The model number is just a minute. 15-DU2009TU. Okay, this is a 10th generation laptop, so it has come for a battery replacement here. So absolutely working fine. There is no issue in this. Okay, see, I'll switch it on and I'll show you. See, there is no issue. Okay. See, but only thing is battery backup not there, so for that reason it has come to me. Now I wanted to inform our PLC students the working principle of this particular laptop. So that's the reason I'm making this video. So it will be very useful to our PLC Pavitra laptop care students. They can easily understand what I'm doing the video. Okay, for them I'm showing all the things. Some experts also can understand this video if they are in this field, particular field. I'll show you what is the model number of this particular laptop. Just a minute. See, this is the laptop. Here it is. See, this one. It's LA-H329P. Okay. Today I'm going to explain all the function of this particular laptop. It's a 10th generation laptop board. Model number is LA-H329P. Step by step I'll show you the working principle to our students. Okay, just a minute. I'll keep it aside. As usual, I'll take a paper. Through the black diagram, I'll show you the function of this particular laptop board. Okay, the board model is LA-H329P, 10th generation board. Okay, it's a 10th generation board. See, in this, it's what is that? Don't afraid to do the service of 10th generation board, because nothing is there as usual what I taught you previously. Same black diagrams will come, just small care you have to take, that's it. Okay, I'll show you by black diagram, you can easily understand. Okay, first as usual, it's a DC jack. Okay, it's a DC jack. DC jack, first one. You know, it comes 19.5 standard voltage I am taking. Here maybe 20 or 21 like that. So next it goes to charging IC. Okay, charging IC will control the battery section. Okay, that you know very well. And this particular voltage goes to CLR. Okay, we'll start from CLR. This voltage goes to multiple sections. Here one by one we can discuss. So next, you know very well which one. It's step down 3-5 section. Okay, here I'm going to tell you the ICs which they are used here. In this, they have used BQ24735. Okay, this already I have explained many times. The function of BQ24735. Okay, it controls battery section as well as VIN section. Finally, you will get the output in CLR. It's considering 19.5 volts VIN voltage. In case of battery, it may be 14.5 to 16 or 12, whatever it may be. Okay, it varies. Here, this 19.5 volts goes to 3-5 section, but here 3 volts is a different and 5 volts is a different. Okay, different IC. In this IC, they have used SY8270C. This is the IC they have used, and in 5 volts section they have used S58286B. Okay, see this particular section first receives the 19 volts, 19.5 volts, whatever it may be, or 20 or 21, depends on input. And next, immediately it will start the LDO, right? LDO will generate 3 and 5 LDO. Okay, these are a separate section. This is a separate IC, this is a separate IC. Okay, this one will generate 3 volts LDO and this one will generate 5 volts LDO. Okay, after this we want what? 3 and 5 always, right? For that, one enable is required, right? Every IC requires enable, that you know very well, right? That enable comes through, what is that? EC underscore on. This is IO, comes from IO. Okay, that you know very well. Once LDO will generates, IO does the function, and it gives EC on, first voltage, to step down IC. Then this will generate 3-5 volts always, right? I already explained. Once again I am going to explain you. This is simple logic. Okay, there is no much difference between 10th generation or first generation, whatever it may be. So all our logics are same. We need to check the particular IC sections. Okay, now 3 volts 5 volts always generated, then it directly here, see, in this volts, one more we have to note it down. Here power good is used, here P good, okay, PG is used, that one called as SPOK. Okay, SPOK is PG. Okay, next this one will goes to where? Again there are two ICs. Here first V will come in this side. Okay, V in, and next on enable will come, that enable called PCH power. Okay, PCH power enable. Once these two comes, then it generates 1.8 volts prime. Okay, and in this IC, as usual, PG will come. It's a 1.8 volts PG. Okay, this IC is called SY8032I. Okay, SY8032I. Here this PG is called 1.8 volts PG, and again here 3 volts also will go, 3 volts always. Okay, and again same 3 volts always will go here also, and V in also will go here. V in is must and should, and 3 or 5 volts, I mean 3 volts will come to this particular IC, and as usual enable should be there. It's called PMSLPS4 hash. The signal is the enable for this IC. Okay, as usual V out, and here PG. Okay, PG is 2.5 volts underscore PG. Okay, this is called step down IC functions. First 19.5 volts, it's a VIN section that is common, that goes to all IC sections circuits. So first IC we will get the step down IC. Once step down IC start works, then it passes to again two ICs. One is 1.8 volts and other one is 2.5 volts. Okay, this should generate before all other voltages, before RAM voltages. Okay, this is common. You can understand, I think so. Yeah, this is not a first time. So continuously, I'm explaining in all the sections. So you people come to know if I repeat it again and again. Okay, it should be in your mind. So you won't lose the logics. Okay, the same logic is used here also. Okay, here now we got 3 volts, 5 volts LDO. Okay, number one. Second one, I am talking about only step down section. Using this 3 volts, 5 volts always we got. Okay, once IO given EC on. Okay, next third one. This 3 5 volts went to here, that 1.8 volts prime generated. Okay, enable is PCH underscore PWR. Okay, this is enable signal, and fourth one is here this IC used S58032I, same IC as used here, 2.5 volts we got. Okay, for this enable is PM SLP S4. This is from PCH. You know very well. Okay, this also PCH. Right? This is the first section. Up to here you have come. Okay, here once it comes, so LED and power on, all voltage will generate. These are the basic voltage. Okay, we come to second point. Here only I'll write. First, as usual, CLR. Okay. Next, it directly gone to 3.5 volt section, and it generates 1.8 volts and 2.5 volts. You already read. And then this CLR directly comes next. Which section? You know very well. Second section is RAM section. Okay, here as usual this 19.5 volts will be the input P in, and second enable signal should be there, right? Enable 1 and enable 2. So here enable is S5 and S3. Okay, here enable S5 is little different one, 2.5 volts, that we already noted here. Okay, this PG, okay, this PG is input of RAM section, S5 section, And second one, it's S3 section. Its enable is SMPG control. Here one enable signal will come. Okay, understood? See, after 3 5 step down IC, next section is RAM section. For that, input as usual V in section CLR voltage, and second one is the 3 5 volts generated 2.5 PG is input enable for this RAM IC. That's called S5 enable, and for S3 enable SM system management PG control. One signal goes to here S3 means from PCH. Okay, as usual, same thing. This will generate what 1.2 volts. That's the DDR4 RAM voltage, and VTT what 0.6 volts Vs. Okay, these volts after pressing the power button it will generate. Understood? This is the output V out, and as usual V out PG. Okay, what we call 0.6 V underscore 0.6 Vs and 1.2 V VDDQ. Okay, these all are output of this coil, this section. Understood? As usual, CLR voltage comes to 3 5 step down IC. It will goes to 1.8 volts and 2.5 volts IC, and this particular 2.5 volts PG is input of RAM section, that is enable S5, and enable S3 is comes from PCH, it's a SMPG control. Okay, then here 2 volts will generate 1.24 2 volts and 0.6 volts Vs. This is the output of RAM section. Got it? This is a 1, 2, 3, and this one is 4. 4 section over. Next, here it's a VCC we call. Okay. Next, this CLR voltage directly goes to this particular section called VCC in. Okay, this one is RT3613 EE, that is the IC. Okay, here as usual it's a V in is the input. Okay, and second one is VR on, VR underscore on is the enable. For this particular IC, VR on enable. It's from IO. Okay. After this enable and input, this will generate V out. What is that? VCC in. Okay. Here, this is the PG we called we are ready. We are ready. Got it right? It's almost maybe 1.8 or 0.8 or 1 volts will be there. Any one voltage will be there in this. Okay. You got my point right. Once again I am repeating, CLR voltage from DC to charging IC to CLR, CLR to 3 5 step down IC, then it generates it goes to 1.8 and 2.5 section, and 2.5 section PG is enable for RAM IC, and one more enable SMPG control is from from PCH, and it will generate 1.2 volts and 0.6 volts output. Okay, after this section VCC in will generate this. For this enable is VR on. Got my point right? Next, same. See, these 3 over and here it's a 4 and this one is 5 steps. Okay, and one more section. Next section, it's a sixth section. Sixth section we called VCC in VCC in underscore auxiliary. This is auxiliary voltage for this VCC in. Okay, here your RTE 6543A IC. Okay, as usual V in is 19.5. Okay, as usual enable should be there, right? Enable is 1.8 prime. See here it generated here. Okay, 1.8 prime should be enable for this IC. Okay, this power good PG. After this enable, as usual V out we call VCC in X. This is the voltage. Okay. For this PG, you know very well. This is PG. The output is called PG underscore VCC in underscore X. Okay. And again, after this, okay, this is 6 point, and now I'll move to 7 point. Okay, I'll write down in different page. 7th point. As usual, CLR on black diagram will directly goes to 7th point plus VGA core. Okay, as usual V in is input, one enable should be there, that's called VRAM underscore PG. It's a VRAM section PG is enabled for this particular section IC. VRAM section is particular section is enabled for this particular section. VGA core. Here it's your RT8812A IC. Okay. As usual, this output you know very well. So I'm using the word as usual, as usual, as usual. You know very well. Okay. You should not get confused or you should not get any type of problem or any big headache. So for that reason, I am telling you these all are very simple. As usual, same circuit input, same circuit output will be there, same circuit having, I mean, same in the same kind of circuit having enable and one output and PG also will be there. That PG is called, here its output is VGA core, that you know very well. That VGA core, multiple times I already explained, VGA core, and this one is GPU PG. Power good. Okay, this power good is called GPU power. This is 7th step. Okay, next, same as usual, same voltage, same CLR is a V in. For next section, it's called 1.35 VGA. Okay, here IC used S58286 R. Okay, here IC used S58286 R. Any IC, whatever it may be. As usual, again V in section is a 19.5 volts and enable should be there. That's called DGPU power enable. Okay, the concept is same for all section. One is input, another one is enable, then it gives output V out is called nothing but 1.35 Vs underscore VGA. Okay, 1.35 volts VGA, and here it's a PG called V RAM underscore PG. This is the eighth section. Got my point right? These are the black diagram of working principle of LA-H329P. Once again, I will repeat as usual. DC jack, from DC jack we will get 19.5 volts according to the, as per the laptop requirement. It will vary, it's a 21 or 20 or 19.5, whatever it may be. It goes to charging IC. Charging IC will control these two section and gives CLR voltage. CLR voltage, as usual, it's a 19.5 or 20 or 21, whatever it may be. That goes to total 8 blacks, minimum 8 blacks. Okay, 8 blacks. And here first it comes to 3-5 volt section. 3 is a separate and 5 is a separate section is there. Here IC used AS58270C, S58286R. And again it's a common thing, one input and one enable in particular section should be there. Once it receives the input, immediately it generates LDO 3-5 volts, then IO will active, then IO will give EC on enable signal to this IC, and this IC will generate one V out. It's 3-5 volts always, this including both I am telling, 3-5 volts always. And this PG is used here. It's a power good section. It's total output. If it is okay, if function is good, then power good we will get, and that power good we call as a SPOK. Okay. Here this particular voltage will goes to next section called, it's a 1.8 prime voltage section. In this particular IC, see as usual V in section input required, so after that one enable is required, and then it gives V out, it's 1.8 volts prime, and here it's a power good, it's 1.8 volts power good, prime power good. Okay, and again it generates 2.5 section also. Again it's a input, it's a CLR voltage input, and enable is a PM SLP S4 hash. It comes from PCH, and again it gives V out, it's a 2.5 volts, and again PG 2.5 volts PG. Okay, and then you know very well, again it goes to some other section that's called where I written, see after this one RAM section. Yes, see, and again I written as a this particular black diagram, and then here 2.5 before RAM section 2.5 will generate. So after this directly it goes to RAM section, RAM IC as usual input is 19 volts V in section, and the two enable it requires. Two enable is, one is S5 and second one is S3. S5 is 2.5 volts power good, and second enable is power management, it's a SM system management PG control. One enable goes to here as a S3, and here it generates 1.2 volts and 0.6 volts VS output as a output. Okay, here this is the PG also required, so the PG we called, it's a 0.6 volts and 1.2 volts VDDQ. They should come output, okay, as a PG. And next section is number 5th one, it's a VCC in section. As usual, V in section is 19.5 volts, and second one is enable is required, so enable is VR on, it's generating from IO, and this will gives power output V out, that's called a VCC in, and this PG is called VR underscore ready. Okay, next is the sixth step. Sixth step is directly goes to VCC in auxiliary. It's one more enable is required, one input is required, one input is 19.5 volts, and one is enable we called, it's a 9.8 prime. It's already 3-5 volts section generated. that 1.8 volts prime section. Okay, and again here PG VCC in auxiliary is a PG power good, and it generates V out as a VCC in auxiliary. Okay. Next. After that, next section is the seventh point. As usual, one more is VGA core. VGA core is a processor core. Core voltage. As usual, this section requires input and enable. Input as a 19.5, and this enable VRAM section PG is the enable for this IC. And again, as usual, V out is a VGA core, and GPU underscore PGD power good for this IC. And next section is the final one. V in 1.35 volts. It's a VGA. It again, as usual, it's input 19.5, and enable DGPU power generator power and okay power enable DGPU power enable goes to enable signal, and then as usual V out is 1.35 VS underscore VGA, and power good is VRAM underscore PG. These are the black diagram of this particular particular motherboard. Okay, these are the working sequence of this particular motherboard. See, motherboard, whatever it may be 10th generation or first generation, whatever it may be, you have to understand the sequence of power or voltage sequence, then only you can rectify the problems. Okay, so now this point, please keep it in your mind. You practice very well. Okay, once you practiced, it will be in your mind, and what are the generation comes, you directly as per the generation or slight variation will be there, that you know very well. So according to the generation, slight variation you can check, but rules will be common. See, in any generation, DC in is a common, charging IC is a common, 3-5 volts is a common, RAM section also common, right? And VCC in, and here these all are in some cases you will get, or some cases different name will be there, and finally you will get core, VGA core is the final one. So VGA graphics core is the final one. So then you will get the output. Okay. If any problem with this particular section, you need to check the particular IC section. That is a diagram of this power sequence of 10th generation LA-H329. Okay, you got it? Please practice well. This video is made for only PLC. It's a Pavitra laptop care, because I already done many chapters to them. For revision purpose, I'm using this 10th generation laptop, and I already explained, and I'm explaining, I concluded also. Thank you very much.